bug fixes as quick as possible. So this often results in incompatible and even contrary mindsets, processes that have been grown over time and that need to be aligned. From a technical perspective, of course, many challenges have to be tackled on an organizational, on a cultural level inside an organization. But on a technical perspective, DevOps is often supported by so-called continuous delivery pipelines. That means pipelines who enable new iterations of the application to be deployed through that pipeline. That means consisting of different stages like build, test stages, and finally the production stage. And most of the stuff is completely automated. That means this also helps to align the processes between developers and operations, independent of how you actually structure your DevOps organization. And this is one thing we are focusing in our research in this context. So a short motivation for continuous delivery on its own. So continuous delivery is of course one practice that could be applied. There are other practices which may be also appropriate. Why is continuous delivery relevant at all nowadays, especially when we look in the fields of applications that are delivered through web applications, cloud-based applications, mobile apps, and also the Internet of Things? Customers and users typically expect quick responses. That means if you are not able to continuously deliver your application and updates and bug fixes and new features, it will be a competitive disadvantage in this case. So it also ensures that you actually build the right product because you tighten the feedback loops to your customers. That means it does not take half a year until the new version or the new features is rolled out to the end user, but it's quite quick, right? In terms of days or at maximum 1 or 2 weeks, let's say, you get a new version out to the customer, you get quick feedback, and you see actually if you are going to the right direction. This brings also some cost reduction because you are avoiding wasted development efforts. That means you do not spend half a year development time in order to develop a feature that's later on shown as, let's say, completely irrelevant or counterproductive for the users. So how could you technically follow this approach? First of all, of course, improving the collaboration on an organizational level. This is, so to speak, the non-technical aspects. But you also need the notion of continuous delivery pipelines in order to implement the automation that's required. That means the idea is you check in the code, the pipeline gets triggered automatically. That means by the continuous delivery pipeline, the code gets checked out, tests are run, unit tests, integration tests, and so on, and you gain basically confidence that the new iteration of the software will work in production properly by passing the different test stages, for example. To make an example, you may have an application which can follow different architectural styles. You could have a more traditional monolithic application or a microservice, for example, which is an independently deployable unit. That means you have a continuous delivery pipeline attached to it. And what a continuous delivery pipeline is essentially is an automated delivery plan. So it implements a delivery automation system which is individually tailored and maintained per deployable unit. That means for each unit, microservice application which is independently deployable, you have a separate pipeline. And in order to operate the pipeline with the different stages, build, test, production, these are just examples. Pipelines can be very individual depending on the application requirements. You need underlying application environment. For example, you need a build and a test environment to run. First of all, you build the binaries, run some unit tests, run some integration tests on it, and also, of course, the production environment to finally deliver the application to the end users. What you may also need in between are some plans, because the environment is basically providing the infrastructure to run the builds, the infrastructure to run the production instances, but you also need some plans on top to carry out the actual actions. For example, to run the build stage is what has to be done, the logic and so on is typically incorporated in such plans, which could be implemented in different ways. So in the title you saw we were focusing on DevOps and especially DevOps solutions. So what is exactly a DevOps solution? It's hard to define, but this is just should somehow outline the scope of what we are looking at. It's basically any kind of building block could be an artifact, a tool, an existing API that is used as building block of an application environment, that means of such an environment. So these black boxes are basically different building blocks. This could be a cloud provider API that allows you to provision a virtual machine on a certain infrastructure in the cloud. It could also be a deployment script that runs on top on a virtual server to provision a certain middleware component. It could also be a pre-packaged virtual machine or container image that encapsulates a certain application component, for example. Right? There are more alternatives. So these are just examples here. And in the scope of this work, we want to look at how we can actually improve the delivery of such DevOps solutions and improve their reusability. So therefore, some concepts are presented. First of all, we are going to look at how collaborative solution repositories can be used in order to allow experts work together and both gathering solutions and also refining existing solutions that can also partly be automatically discovered and captured in such repositories. The next step would be the automated discovery, because if you have a large set of solutions and there are plenty of active communities out there. For example, there's a chef supermarket which provides chef cookbooks that are reusable deployment scripts for certain middleware components, for example. There is Docker Hub, which provides a huge set of pre-built application container images that you could potentially reuse in different application stacks. How could you automate the discovery and capturing of such solutions and store them inside collaborative solution repositories that we outlined before? And the last point will then be about applying continuous delivery to the idea of not only delivering applications, as was originally the idea, but also different kinds of knowledge-based variants that can then be utilized to find out proper solutions for a certain application environment. Then we present a framework that integrates and implements the approaches and will have some conclusions. So first of all, when we have looked at, for example, in the open source community, how software projects are run, it's very often based, if you look at, for example, large and small scale software projects on GitHub and other platforms. There's not only the GitHub, but GitLab, for example, is also a platform which can be hosted on-premise, for example, in the scope of a single company. You see that these platforms are quite popular because they provide a means version control of repositories. That means you can check in code, you can also check in any kind of preferably textual documents like documentation, metadata, configuration definitions that are basically attached to your application. And you basically gain a large degree of provenance and transparency, because each and everything that's part of the application and every change that is made is basically documented in the version control system. That means when you go further and also add, for example, when you think of infrastructure as code, the idea of automating the deployment in terms of implementing scripts, and also put these logic into the repositories, then you have a quite self-contained way of having everything versioned and documented inside these repositories. So it's, as I said, it's more than just code, even though these repositories that are, for example, based on Git or similar technologies are often referred to as code repositories. In practice, there's more than just code. For example, you have documentation using markdown files, you have deployment plans using different kinds of scripting languages and so on. And in addition, such platforms, for example, GitHub and GitLab, they provide you additional features on top of these repositories to improve the collaboration between developers and operations and other experts that are working on this piece of software. For example, you have pull requests to propose a certain change to a repository. You have code review facilities. You have the ability to branch and merge a certain base and variant of the software. And in addition, there are also standards and de facto standards evolving. For example, Git is becoming quite popular and used by actually many projects, not only in the open source space, but also inside more and more companies. So the important message is that experts like developers and operations personnel, they are pretty much familiar with those concepts. So they know how Git works, they know how to deal with JSON documents and so on. So it would be a good idea, for example, to reuse these established practices to also cover, let's say, reusable DevOps solution outside the scope of specific application stacks, which are then reusable in different contexts. And this is exactly the idea of a solution repository or solution and metadata repository, to be exact, to adapt the concepts of this code repository for managing solutions, and basically to store the metadata of different kinds of DevOps solutions that can then be used to establish the application environments as part of such pipelines that we have seen before. Right? And you could either have a reference to the actual solution that is described by the metadata, or you store the solution inside the repository. This is more of an implementation detail. You could, for example, express using file-based structured documents inside such repositories, using different markup languages like JSON, YAML, or XML. These metadata, for example, you can first of all specify URI, which uniquely identifies a particular artifact. Then you define uniquely a set of labels which explain what are the specific capabilities. I will talk about the labels in a second. Here, in this sense, it means basically this artifact provides a certain middleware components of type web server, in particular an Apache HTTP server implementation. It is an executable, to be more specific, chef cookbook, which is a deployment script. And then you can also express links to other solutions, let's say. Because in this case, so this is a chef cookbook which does not run on its own. It's not a cloud provider API that you can just invoke, but you actually need some infrastructure to run that. That means you have a requires host dependency in this case. So you need, for example, in this simplified case, a Debian Linux system to run this solution on. That means this solution is only appropriate if you have an infrastructure that has Debian, for example. Of course, you could also express it using other markup languages. This is the detail. So the taxonomies I have already showed quickly yesterday. The idea of these taxonomies is basically to classify, first of all, the implementation in various dimensions. For example, here you see the type dimension. That means we can use these taxonomies, which were derived from let's say, established categorization means that are, for example, used by different cloud providers, platform as a service providers, but also some categorization efforts that are made, for example, in public repositories that try to categorize existing solutions. And the idea is that you use such a taxonomy to describe what is the actual type of the solution that is provided here. For example, Java runtime, a MySQL database, which is a relational database, or some kind of deployment tooling that's also required. For example, if you decide to go for a certain artifact that's stored as a DevOps solution, you need also the underlying infrastructure in terms of the execution environment. If you go for a chef cookbook, you obviously need a chef runtime environment in order to execute it, right? This is another dependency you have to think of, right? If you are not willing to introduce chef in your landscape, let's say, then you might go for you might prefer another solution. So these taxonomies are also codified, so to speak, as structured documents and put into the solution repository, because these are also changed, or these also change over time. When you think of new kinds of solutions coming in, or what you see here, sometimes some categories of solutions are grouped under different names because different communities use different names for the same kinds of solutions, let's say, but different terminologies have established. You can define aliases, which helps you later on find out, okay, this is actually a deployment automation solution, or this is actually a specific NoSQL database solution that is provided. And by storing these taxonomies also in the repository helps you basically to collaboratively evolve also with these taxonomies. When, for example, new solutions are coming in, you need to refine some categories and so on. So the next step would be, of course, these solution repositories could be now managed fully manually by experts, but this is of course a lot of effort, especially if you think that existing repositories try already to provide solutions and enrich and provide certain metadata regarding these solutions. For example, when you think about the chef supermarket, which provides you already a huge set of reusable artifacts, including metadata describing what are the input attributes and so on, it would be nice to automatically retrieve these solutions and store them in solution repositories in this normalized way that we have seen. So the idea would be to have some kind of discovery, targeted discovery. That means you point explicitly, for example, to the chef supermarket or a Docker hub, and where are potential candidates to find it, for example, in some GitHub repositories, wherever. Then you can, then first of all, the discovery step is made to find out where the solutions are stored. When you have some kind of retrieval, that means you resolve the reference, for example, URL to a Git repository or an HTTP endpoint. You can retrieve the raw solution, you can extract it. You can normalize the metadata. That means finding out, okay, in the chef book there is already a metadata file which can be read, which can be extracted, and then put into a normalized format, and then finally be stored in a solution repository. There's an optional enrichment. For example, you can try to automatically classify this artifact already based on document classification techniques to find out, okay, this, according to some keywords it has in it, is most probably a MySQL implementation. So according to the label taxonomy, you can already put in some labels to describe the capabilities of this specific solution. And then the next step would be the continuous delivery of knowledge-based variants, because we are still here in the solution repositories, and as we have seen, of course you can do some full text search and find, okay, this is a solution that has some MySQL keyword or whatever inside, but you cannot do any fine-grained queries. For example, you are looking for solutions of a certain, that are categorized, for example, as relational database that run on an Ubuntu operating system and so on. So these kind of fine-grained queries are typically not possible based on these version-controlled repositories such as Git and Subversion and so on. And therefore, the idea is to deliver different kinds of knowledge-based variants. Based on these steps, you could first of all aggregate solutions from potentially different repositories. So you can also think of, you have some solution repositories that are publicly available as open source, for example, stored on GitHub. But these could be also enriched by some private solution repositories that are company internal, that have some specific solutions only relevant in the scope of a certain organization. And therefore, you can now aggregate, for example, a public one with a specific one that's internal to your company. And as a result, of course, there are some steps in between, very similar to a continuous delivery pipeline of an application. You optimize, you test, for example, you do some consistency checks. If the metadata, for example, comply to the label taxonomies, you can finally build an instance of the knowledge base by rendering, for example, the retrieved solutions, so by importing the structured documents into a database management system or an Elasticsearch backend. And then this makes up, finally, the deployment of the specific knowledge base variant. Let's make a concrete example looking at the gather-based framework that we try to establish in this scope. So it consists of two major building blocks, the auto-gather pipeline and the deliver knowledge base pipeline. The auto-gather pipeline, let's make a zoom in, basically covers the automated discovery and capturing of solutions. That means it's basically an extensible framework that can be enriched by discoverers, which first of all try to find existing solutions of a certain type. For example, the chef discoverer would go to the chef supermarket and try to find out what existing cookbooks do exist, what can we actually use from there. Juju Discoverer would go to the Juju Charm store, for example, to find similar artifacts and so on. And this can be extended to Docker Hub, whatever you want to discover. Then you have different kinds of retrievers because these artifacts can be stored in different ways. So there are different kinds of channels that we use in order to retrieve the artifact, like checking out a repository, retrieving an HTTP URL, and so on. And these phases or these tiers are basically connected using queues. You have basically for each, so when a discoverer finds a new artifact, it puts a retriever job queue, and then the corresponding retriever is responsible for getting the artifact first of all. And then you have some handling logic, that means again a job queue in between. For example, to extract the artifact, to write it to a certain solution repository. Here again, the classifier can be used as a separate module, first of all to read the label taxonomies, which, as I said in the beginning, is also stored in the solution repositories to find out under which categories this particular solution can be classified. And then, of course, experts can either refine existing solutions or put additional solutions which are not automatically discovered, because solutions that are automatically discovered are just a subset of the solutions that do exist. And then the second part would be the delivery of the knowledge-based variants. That means the goal was here to follow the steps that were outlined before and to establish a certain ecosystem of reusable modules, to build specific pipelines in order to deliver different variants of the knowledge base. For example, you could have a reader that first of all retrieves solutions, metadata from the repository. You can do some filtering, for example, to filter out any solutions that have a certain license that is not compatible with your organization. For example, you may exclude GPL license solutions and so on. You may have some deduplication to find out, okay, some solutions are actually the same that are stored, or I have the same solution stored in my internal repository as it's already stored in the public one. This is the goal here. You can normalize the labels, do some validation. And finally, during build and deploy, you can choose how you actually want to render the knowledge base. This depends on what kind of interface you want to provide to the users or the experts in order to utilize the knowledge base with the corresponding interface. For example, you could render it as an Elasticsearch backend with a web UI on top, which is finally delivered as a Docker container that you can use on your machine. Or you could basically render the knowledge base in a MySQL relational database with a REST API on top, which is, for example, hosted on Amazon. These are just two examples, right? And then you can use the query mechanisms that is provided by the particular solution that you selected in order to render the knowledge base. For example, if you go for the Elasticsearch option, then you could use the existing Elasticsearch query language in order to query the knowledge base correspondingly. Just 1 minute. To wrap up, the main contributions that we just presented were basically the idea of collaborative solution repositories by adapting the concepts of code repositories to managing solutions and their metadata. The automated discovery as well as the continuous delivery of different variants of the knowledge base. And then we also saw the gather-based framework as an example of how you could actually realize these concepts. In terms of future work, we aim to enrich the ecosystem of modules to evaluate and compare very diverse variants of the knowledge base and try to find out which is the most suitable one for certain use cases, and also transfer the approach to other domains, because the framework and the idea itself is generic enough to not only consider DevOps solutions, but maybe also, for example, interesting in the domain of Internet of Things to connect devices and find out how to relate stuff. Thanks a lot for your attention. If you have any quick questions.
Thank you very much, Johannes. Some questions, please? Yeah.
I just have one remark. Why don't you use the term, or let's phrase it the other way around. You start with a solution base, then you do some work, and then you call it a knowledge base. Why isn't this also a solution base? So why do you introduce a new term that is difficult to define? This one over there.
Why here's knowledge base?
Well,
yeah.
It's also a solution base, right?
it's so it's actually the same information structured in a different way. That's true. It could be aligned. The idea is, and that this is actually a knowledge base that is directly usable by users in the sense of retrieving knowledge, because this is more on the management level. Here you manage the different and maintain the different solutions, so it's much more centered about the individual solutions. Here it's because in this phase the solutions are also linked. Here the links are just defined, and during the delivery and build process the solutions get interlinked, and therefore you have an interlinked let's say base of solutions, right?
Even a better solution than what you termed solution before. I'm just wondering that.
Yeah, but that's a valid discussion.
Yeah,
absolutely.
Because it may lead to different area.
I know. Knowledge base is a very broad term, different. I know. Very good point. Thanks.
Okay, somebody's more contributions to the discussion. Nobody else?
Thanks.
Again. The next speaker comes from the University of Naples.